Hello guys, welcome to another video on the ALS Software Engineering program. Today we'll be looking at the project 0x12.c single linked list. And the first question is, what is single linked list? So if you look at this GIF here, you will notice that these people, they are jumping from one place to another and they are actually going to one direction. So let me just give more explanation. Okay, so a single linked list is like a container, right, that holds a value. So let me say this is a container and it holds the value 2, and at the same time it is pointing to another container. Okay, so the first container, which has the value 2, is pointing to another container, which is 3, and the second container is pointing to another container, and this container, it holds the value 4. So this container, right, is called node, right? So basically it means one node is pointing to another node, right? And each node has its own value. Okay, so let us look at the visual representation of a single linked list. So here I am on visualargo.net and I am on the linked list slide. So let me create an empty linked list, for example. So I've created an empty linked list and you can see my linked list is what? Empty. So the first thing I want to do is to insert a value into my linked list, and I want to insert it at the head. Okay, so let me insert 5. I want to insert the value 5 to the linked list, so I'm going to click on this. Okay, if you notice the animation here, and you will notice that the number I inserted is now the head and the tail. Okay, so let me insert another value. So I'm going to insert at the head. Before I insert at the head, I want you to look at this part here by my right hand side, right? So if you look at this, and you will see that the vertex is the node, so the value we entered is the new node, and since there is no new element, all we need to do is to set the head as the head and the tail towards the new node. Okay, so let me impute my second value. So I'm going to impute the value 6 and enter. So if you look at the animation closely, you will see that the new value I just entered is 6, and the value is now what? The head is now pointing toward the tail. Tail is now having the value 5. Let me insert one more value. Okay, so I'm going to insert 7. So you can see every value I inserted to the linked list is what? Is going to be from the head, because I am inserting it from what? The head. So the head is pointing to the next node, and the next node has the value 6, and the next node, which is the center node that has the value 6, is pointing to the tail. So a linked list has what? A head and a tail. This is very important. Okay, so we can also insert at a particular index, and we can also insert from the tail. Okay, so let me insert after the tail. Okay, so I'm going to insert the number 31 after the last tail. So you can see all we need to do here is point. Yes, if you look at the code here, you can see this is the new node we've created, and all we need to do is to point the current tail of the next item to the new node, and we assign the tail as what? The new node we've created. Okay, so let me clear this. And let me create a random node. Okay, so basically you can see this is what the head and this is the tail. So the takeaway here is a linked list is likened to a container that holds a value and also pointing to the next container. So it's like a chain. They are chained together. Okay, there are some inbuilt methods we can work with. Okay, I'm trying to see. Okay, yes, we can also search for an item in a linked list. So let me say, for example, we want to search for the value 7 in a linked list. So I'm going to click on Go, and you can see if you look at the animation, right, it starts from the head and it goes all the way to the last. And since it is not found, it should return null or -1. So what if we decide to search for an item that exists? So I want to search for 90, for example. So I'm going to click on Go, and you can see it starts from the head also and move to that node. And when it gets to that node, it returns what? The index. So you can see the code here. This is the code sample, right? So it says yTemp.item. The temp is the temporary head. So y value exists. So keep on moving to keep on assigning the temp to the next item. But if nothing is found, definitely we should return null, which is the item is not found. Okay, so I hope this gives you a clear picture and a visual understanding of how a linked list works. So let us look at some code example. So here I am on our online compiler, which is the Programmist. Okay, so this is like a basic linked list. So this is what the structure of the node in the linked list. And I have some method which is append. It adds a new node to the end of the list. Okay, so I also have another method which is what? Print list. What this function does is to print the content of the linked list. And I have this method which free up the memory used by what? A linked list. So here is our main method, and in our main method we'll be adding values to the linked list. You can see this value are added to the linked list, and we decide to print what we have in the linked list. And lastly, we free up the memory used in the linked list. Okay, so I'm going to run this. So the value are assigned in the linked list are being printed out by this method, which is the print list. So you can see 1 first. I decide to append 1 first, 2, 3, 4, 5. Okay, I can decide to append one more. Sorry, let me copy this line. I can decide to append one more. So let me append 25. So you can see 25 is now the tail. So my own linked list is currently limited because there are a whole lot of methods we can have in the linked list. We can insert by index, we can insert from we can insert from the head here. But what I am doing is append from the tail. So this is like a basic example. All right, so I hope this gives you like a clear picture of how links work. So guys, thank you very much. I will see you in the quiz section. All right guys, welcome to the quiz section. And the first question in the quiz section says, what is the tail of a linked list? So the correct answer is, it is the node with the pointer to the next equal to null. So tail is always pointing to what? North. The second question, which is question 1, so it says, what is the head of a linked list? Definitely from the example I've given, we should know that the head of a linked list it is the first node. Question 2 says, what is a node? Right? So these are the correct answer. It is a space allocated memory. Then it is a structure with a pointer to the next node and value information. So just like the example I've given, is like a container and it points to the next node. Question 3 says array versus linked list. Select all true statements. Okay, so these are the correct answer, right? Linked list can contain as value a structure. Then memory align is aligned for an array. Each element are back to back in the memory. Okay, we can add elements indefinitely to a linked list. Array can contain as value a structure. Then we can easily remove an element from a linked list. Okay, so let's go to question 4, which is the last question. It says, in a single linked list, what is the possible direction to traverse? So it is always what? Forward. You always traverse what? Forward. Alright, so thank you guys for watching. I'll see you in the tags section. Hello guys, welcome to the tags section. Before getting to the tags section, I am very sure you must have read the project requirement. Okay, so with that, let us move straight to the project. So the first thing we want to do is to create a file that holds our prototype. So you can see this is the prototype for this tag cell, and if you look, they said the prototype name should be list.a here. So quickly, let us do that. So here I am in my cloud server. Okay, so I've run the command pwd. You can see my present directory is ALS low level programming. So to know our current directory for this project, you have to scroll down to this section and you can see this is our project directory, the 0x12. So I'm going to create that directory and navigate into that directory. You can see the directory is what? Empty. The first thing we need to do here is to create our readme.md file. And the readme file should not be empty. It can contain all basic information of what you want to achieve, but for me, I will just post the name of the current project. So the next thing we should do is to create our header file, which is what? The list.h. Our header file is going to hold all our prototype. Okay, so I've already created mine. So if you want to create yours, all you need to do is to run this command list.h. So this file is going to hold all the prototype. All you need to do is to copy all the prototype and paste it there. Okay, so let me show you mine. So here is my prototype. You can see I decided to do this once. You can copy this. I decided to do this once so that I don't need to go to that file again, because this is another prototype. You can copy all of them and put it in that file so that you are certain that you are done with the file. You can decide to test that file. You can see the file is okay. So you do not need to go to the file again once you have copied all your prototype. So the next thing is to write the solution for tag 0. It says write a function that prints all elements of a list, just like the example I gave on the online compiler. So we should print what? All elements in a linked list. Okay, so they're giving us the linked list already. All we need to do is to print the elements in the linked list. So note the prototype, okay, and the type of permission with it, which is it should return the number of node. Okay, you can see these are what the examples. All right, so here's my solution. Note the name of the file first. This should be the name of the file, 0-print_list.c. So once you're done with your solution, right, you can see my solution. The next thing I want to do is I want to make that file an executable. Okay, I want to give the permission to execute that file, so I'm going to just use 744 and follow by the name of the file. In fact, everything. So if you do ls-l, you can see and I have executable access to this file. So the next step is to test our file with the given example. So you can see they're giving us a file which is the 0-main. So we need to create this file, vim 0-main.c, enter. Then we need to copy the content of this test file they're giving us. So this is the end part, straight to the top here. I'm going to copy that file, paste it, and regular colon wq and save. So you can see we now have what? One new file. So let me also make this file executable. Okay, so the next step we want to do is to go to this section. So we need to compile our file. So I'm going to copy this command from the GCC, Ctrl+C to copy, and we need to run that command. So the command has been copied to my cloud server, and all I need to do is to press enter. If there is no error, it means we're on the right path. But let me do ls-l. If you notice, we now have a new file. So we need to execute this file. This is an executable file that was generated running the previous command. So we need to run this file. You can see that is the next step here. So let us run that file. So we have this result. What we need to do is to check if we're having the same result as the one in the example. So this is telling us two elements, right? The first one is hello world, 2 word, and the other one is nail and word, 2 element. So you can see we are having what? The same result. So this shows we've done well, and what we want to do is to do our git add, git commit -m. You can write a meaningful message, but me, I just want to write done with tags. Cool. The next thing I will do is to do my git push. I'm not going to push because this is an example. So once you've done that, you just need to come and check your code and start a new test. Once everything is good, you should see this green here will be highlighted and you are getting a congratulations message. All tests passed successfully. The next thing to do is to go to the next task, and it says write a function that returns the number of elements in a linked list. Okay, you can see they are different. This one says write a function that prints all elements in a linked list. By this time, they are telling us write a function that returns the number of elements in a linked list. Okay, so they are giving us example here. We also have a prototype, and remember we've added all the prototype into the list.h file. So the next thing we want to do is to write our solution in this file. Note the example have been given to us here, but we'll come back to this. So let me get my solution. Okay. Okay, I'm trying to get my solution. Okay, let me know the name of the file, one-list.len. Okay, you can see I now have what my solution, which is one.list.len. Enter. Okay, so let me clear my screen. The next thing we want to do is to create the test file they've given us, right? Which is the one-main.c file. So I'm going to copy that file up to this point. Ctrl C and vim one-main.c. Enter. I for insert, and I'm going to paste the content I copied. Escape regular :wq to save. So if we check, we now have what? Two files to change their permission. So to change our permission, we can use chmod 774 or 777 as it may be to allow everybody. So the name of the file, one-listlen and one-main. Enter. If we check now, we now have executable access to this file. So if you go to our project resource, the next thing we want to do is to run the gcc command so that we can generate the file called B. That file is an executable file. So I'm going to paste the command, and if we press enter, if there is no error, it means everything is good. So I'm going to press enter, and if we check, we now have a new file called B. The next thing we want to run is that file. We want to check if we'll get the same result. So /b, enter. So my result is 2 elements. And let us look at the one we have on the web. It says 2 elements. So it means we are on the right path. So all you want to do is your git add, git commit -m, done with tags 1, and git push. So next thing you want to do is to go to your next task. So this is like a basic example of how you need to work on your project, but I believe you also follow the same pattern. You write your solution, you test your file, just follow that and you'll be successful with the project. So alright guys, thank you very much for watching. Make sure you like and subscribe. I am going to cover a more comprehensive tutorial on algorithm. So ensure you subscribe, like, and set the notification bell in order to get notification of my new videos. Thank you very much for watching. I'll see you in another video.